And then result extraction for piles, so 1D, 2D, and 3D elements will be sort of going over how to extract those types of results. So this is what our finished model will look like. So as you can see, there are 4 different layers here with 3 different material attributes, one sand, one sandy gravel, and one clay. And the centerpiece here is where the excavation will be done, as well as the piles will be installed. So this is just a piece or an image of what this excavation sequence will look like. So we'll separate the excavation into 3 main sequences, 1, 2, and then 3. And then the remaining construction stages will involve installing this retaining wall as well as installing these piles. And then later on, this raft will be poured on and this attribute will be changed. And I'll be discussing that in detail during the demonstration. Okay, and then last we'll be going over the results. So this is what the final model will look like. This just shows the deformation in and around the excavation stage. So this is an exaggerated deformation, and I'll show you how to sort of toggle those options later on. And then we'll also be going over the 1D elements or the piles, so we'll be able to get the shear and the moment diagrams for all of the piles involved. And then last I'll be showing you how to use a very useful function called the define plane option, where you can actually sort of clip the plane, or you can clip the your model along a certain plane to see what your results look like. So you can get your cross sections of your model. Okay. So now let's open up the program. And here's just the start screen of Midas GTS. So for those of you who are wondering, the work plane is currently in the YZ plane, as you can tell by the grid here. But if you want to change it around, you can double click to the left here on your work menu, and you can change your work plane accordingly. Okay, so let's keep it on the Z or on the YX plane for now. And then let's do our geometry. So in order to create geometry in GTS, there's several different options that are available to you. So here you have the different options for curves, rectangles, arcs, etc. So I won't go into too much detail about the geometry yet, but for now let's just start with our top section, which is the rectangle, which will represent our solid for our soil. So if I click on this option here, I have a special option for rectangles in 2D. If I click on it, this option comes up, so I can create my rectangle by selecting 3 points or by going from a diagonal to diagonal. So what I'll do is I'll just go from diagonal to diagonal, and I'll start with my first point, which will be the origin. As you can see, it starts there. And then it'll just ask me for the relative next point. So my next point will be 60 by 60. And as you can see, here's my first rectangle, which will represent my main soil. Now let's do the sort of the rectangle within the rectangle that represents the excavation. So the dimensions, or the first point, is 18, 21. And there it is. And then the next point from there would be, it would move over 24 in the X direction, and then 18 in the Y direction. So there's my second. Okay, so there's sort of the main sort of frame of my geometry. So next, what I'll do is I'll import my specific points for my piles. So the best way to do that would just be to have the spreadsheet ready in Excel. So that's what I have. So let's go to geometry, then point, and then tabular input. So this is a particularly useful option. So if you select this, as you can see, it asks for a point coordinate table. So I have a spreadsheet available in Excel where I have all the coordinates for my piles created already. So let's bring that up right now. Okay, so as you can see, I have all of my coordinates just plotted out in the X, Y, and Z coordinates. So all I need to do is copy and paste. So I'll copy from this spreadsheet. And then I'll select this box. And then I'll press Control V. Now as you can see, all of the coordinates are just imported directly. Then I'll select, and then what I want to do is I want to make sure my coordinates are correct. So if you go to the bottom left here, that'll show you a preview of what the coordinates will look like. And as you can see, there they are. So that checks out, so let's press OK. So now all of my coordinates are ready over there. Okay, so now because my piles, those are just sort of the tops of my piles. So what I want to do is I want to translate, excuse me, I want to translate these coordinates down a certain length in the z direction. So in order to do that, just go to Geometry and then Translate. Then I'll select these piles, or these points here. Then I need to select the direction I want to translate them in, so it'll be the z direction. And now the distance will be negative 10.3. And then I want to make a uniform copy. So it's really important to check this option on, because if you leave it under Move, it'll just move your points. It won't create a copy of it. So let's take a preview here by pressing this button. Okay, that looks good. And click Apply. So as you can see, I was able to translate all of my coordinates through that option. So as you become more accustomed with the software, all of these options will become more familiar with you, and you'll be able to use them with much more ease. So now that I have my nodes for my piles, the next thing I need to do is to connect these nodes with curves. So just go to Curve, and then go to Create 3D Line. So before I continue, I just want to point out that as you can see, you have 2D curves, and then you also have 3D curves, or 3D geometry over here. So whenever you're working outside of the work plane, so the work plane is in the YX area, as you can see, you need to make sure to select 3D. Otherwise, you won't be able to extrude or to work in the plane that you desire. So anyway, I'm making sure to select 3D line here. And what I need to do is just need to check or to connect all of these nodes. And this will just take a minute. But as you can see, it's fairly simple. And I can just use the mouse to scroll in to get a better view. And if I want to, say, move it over, to rotate it, just click down on the scroll button, and you'll be able to move it over. Okay, so this will just take another minute. Okay, so these curves here will eventually become my piles, but I have yet to assign them material properties. So right now the program just recognizes them as a set of lines, but later on when I'm doing my meshing, I'll be able to assign all of my material properties to these piles. Okay. All right, so now we have just the basic frame of what our project will look like. So next, what I need to do is I need to extrude this top layer here, this portion, to create 3D geometry. So in order to create objects in 3D, it's always best to create all of your 2D planar geometry first, then extrude it into 3D. So if you just go to Geometry, or actually if you go to Solid, excuse me. So if you go to Solid, as you can see, it goes from 1D to 3D. So curves are all your 1D elements, surfaces are all of your 2D plate elements, and solids are all of your 3D solid elements. So in order to create your solid elements, just go to Solid and then click on this icon here. And it says Extrude. So what you need to do is now is you need to select your extrusion profile. So first we're going to select this wireframe here. But as you can see, I can't really select it right now. I mean, I'm going over the line, but the program is not highlighting, which means I can't select it. So what I need to do is I need to go to this option here, bring down this drop-down menu and select wire instead. So this is your selection menu or your selection filter, and this will help you decide, or this will tell the program what type of elements you want to select. So now I change it to wire, and as you can see, now I can select the rectangle as I'd like. So now just click on that, and then select the extrusion direction, which will be the Z direction. So just click on the axis there, and next select your length. So for this first layer, I'll make it 3 feet deep, and then since it's going in the negative Z direction, check on reverse direction, otherwise it'll go in the positive Z direction. And then this is always a good rule of thumb, make sure that you name every solid element that you create as you're creating it, otherwise you'll have to go back and rename everything. So this is a much more convenient way to do it. So let's name this Excavation 1. And then click Preview here just to make sure before you create anything that it's what you want. Perfect. So click Apply. So that's my first sort of section here, my first layer of my excavation. And then if I go to geometry to the work menu, and if I go down to solid, as you can see, it's been recorded. So this work menu becomes more and more prevalent as the scope and the size of your model grows larger. So that way everything is sort of categorized and organized for you so that you can refer to it later. And if I want to check it off, I would just turn that off and I'd be able to see things better. Okay, but we'll leave it on for now. So now I just need to create my remaining layers. So let's do that. So once again, just go to geometry, or excuse me, go to solid, select the extrude option, and then select your extrusion profile. So I want to change this to wire once again. And this gets a little tricky. I need to select that bottom profile. There we go. Oh, I had it. There we go. Then select the extrusion direction, negative Z direction. The length, this one will be 7, and I'll name this excavation 2. I'll preview it real quick. Oops, I forgot to click reverse direction, so it's in the positive. So let's check this on now. And now it's in the negative direction. So it's always a good rule of thumb to just preview whatever you create before you create it. So we'll click apply. And there's my second layer. And now it's just the same for the raft and then for the embedded limit. So I'll do that real quick. Now as you can see, the piles are sort of in my way, so let me just turn those off for you. Or actually, never mind, I'll do that later. So yeah, I'll select the extrusion profile, the direction. Make sure to check on wire. So when you're selecting the bottom sort of layer here, or the bottom wireframe, just go to the corner, and then you just sort of have to navigate the cursor up to a certain edge where it'll select the wireframe. So this can be a little tricky, as you can see. I selected it a couple of times, but I keep moving over it. There it is. So now, just create the length, which I believe is 0.6 for the raft. Check on the reverse direction, and just name it raft. Okay, there we go. Okay, so now I need one more layer for my final limit for the final part of the excavation. This part actually won't be excavated itself, it's just sort of the embedded limit for the piles. So this is the soil layer where the piles will be sort of embedded into. So select the extrusion profile. Go to that corner there. Select the direction, which is the Z direction. And then this final one is 2 feet, or excuse me, 2 meters in the negative Z direction. And then name this embedded limit. Okay. And there we have it. And then let's check our solids here just to make sure everything's named correctly, everything corresponds. And to get a better view, just go over here. And all of your view options are over here. So if you want to get your side view, your top view, your rear view, etc., you can just click on these icons. Okay, so now we have my excavation layers. The next thing I need to do is to create my solid layer, my surrounding soil layer. So in order to do that, it's the same process. Just select extrude, select your wireframe, this outside portion here. Select the direction, so it'll be the negative Z direction, and it'll be 40 meters deep. And let's name this just soil. Let's preview real quick, and then apply. Okay, so now we have the basis or the foundation of our 3D geometry. So it's fairly simple with the specialized commands that Midas GTS has included. And as I'm sure that you can all imagine, there's many more sort of more complex and more detailed commands, but this is more of a sort of straightforward foundational tutorial. Later on, when you're having maybe more complex projects with more complex geometry, we can have specialized customized sessions to help you sort of create those models. Okay, so now that I have this created, the next thing I want to do is I want to embed this excavation layer or this excavation piece into the soil. So in other words, the program doesn't recognize that this embedded layer, or that this excavation is hollowed out. So in order to sort of hollow out this excavation section, I need to do a Boolean cut. So in order to do that, just go to Geometry and select a Boolean operation, and you have all of them here, so fuse, cut, and common. So we'll talk more about fuse and common later on, but for now let's focus on cut. And just to show you all, under solid, you can access that option here as well if you want to become familiar with the icons. So Boolean cut. So first select the master solid. So essentially the master solid is a solid that's being cut. So that would be the soil itself, the large soil boundary. Now select Boolean tools. So you can select as many tools as you'd like. So what we'll do is we'll select all the excavation layers, because all of those excavation layers will be cut out of the solid. So I could go onto the work menu, or the work window to select them, but that's a little troublesome. So an easier way to do it would just be to go to your work window and select all the layers. So just select excavation 1 and hold down Control as you select them, so you can select all of them. And then make sure to turn off delete tool objects. If you leave on delete tool objects, what will happen is all of these layers will be deleted after you perform the cut, and we don't want that. We need those layers later on, so we'll keep them here. And then go to preview. As you can see, this is just a preview of what it'll look like. So now, as you can see, the program recognizes that this area is cut by these solids here. So we'll click Apply. And as you can see, as we select excavation 1, 2, the raft and the embedded limit, it gets deeper and deeper. So that's how you would sort of embed or cut your layers, or the excavation layers. Okay, so now that that's done, the next thing I need to do is to create my soil layers, or my soil strata. So first let's change it to the side view so we can get a better look at what we're dealing with here. And then also, as you can see, what I want to do is I want to draw certain lines or curves along the face of the soil layer. But as you can see, my work plane is still on the XY plane, or this top plane here. So first let's change that. So go to work plane, and I believe we'll change it to, I think, XZ. There we go. So now the work plane is over here. So now I can draw 2D curves just along this plane. So it makes it much easier to do my drawing. So once again, press this option here to get your side view, or your front view. And now let's draw some soil strata. So as Aaron alluded to, a really great advantage of GTS is that it's able to create very complex or very detailed geometry. So for example, in other programs such as Plaxis and GeoStudio, you can only create level strata, but with GTS, you have the option to create asymmetric strata and detailed contours. So I'll show you how to just draw some asymmetric strata. So first, just go to Curve, select 2D line, and let's draw our first one. So for this first layer, let's make it 0, -20. Let's see what that looks like. Okay, so that's still kind of high, so let's I'll cancel that one. Let's make it 0, -30 instead. Okay, that's a little better. So what I'll do is I'll just make some arbitrary slopes. So obviously, when you're creating your actual project, you'd have actual soil strata. But since this is just a demo, let's just say, for the sake of argument, that your slope has this kind of aspect ratio. And what you can do actually is you can just draw over it. You can just get a good sort of estimate of where the slope is, and then just create your curve. So that'll be my first curve. And what I can do is I can just trim this edge here. Just go over here to this command, trim. Just select your base, then press Enter, and then just select that. So as you can see, it's just trimmed for you. And also, let's create sort of a jagged or a two-plane type of strata. So go to Curve, 2D line, and let's make this one 0, -20. Okay, so this one, it'll dip down over here, and then it'll come back up. So that's the second type of soil strata you might have. And then once again, just trim it. So select your base and then cut off the edge. Okay. So as you can see, I'll go back to the 3D view. I have two different soil strata layers, both of which are uneven or not level. But currently, there are only curves along the side of this face here. So in order to create the soil strata, what I'll have to do is I'll have to project these curves onto the other side of the soil, and while doing so, I'll also have to create faces or surfaces. So in order to do that, just go to Geometry, and then go to, go to Project. So go to Project Shape. So it's the option is here somewhere, but the thing is I'm more familiar with just the icons. So I'll figure that out later, but project. So first off, select your target surface or the face or the surface that you want to project your shape onto. So it'll just be this opposite side here. So that's my first step. Now I need to select my tool curves. So let's select these three curves. And then select the direction. So it'll be the Z direction. And then also make sure to check on this option, Make Face. So this is particularly important because if you don't select this option, what will happen is these shapes will just be imprinted onto this other side or to this face, but there won't be an actual frame with a surface in between. And what I'll do is I'll show you what it looks like. But first, let's take a check. So as you can see, the curves are being projected while also having this sort of line here that represents the frame. And within that line, there will be a face or a surface that we'll use to cut our soil layers. So that looks good. Click Apply. And now we have our first two soil strata layers. And let's get a better look at them here. So let's turn off all the solids. And as you can see, we have one face here, and then we also have sort of two faces that represent the second strata. So in order to later on to cut my geometry, what I'll do is I'll need to merge these two faces into a single plane. So in order to do that, go to Surface, and then select this option. So it'll ask you for the surfaces you want to sew. So you want this surface and this surface. We want to merge the faces. We want to delete the original shape. So essentially what that's telling you is that instead of just having two separate shapes, we'll just have one shape that will represent this surface. And then just click Apply. Okay, so it changes colors to let you know that, okay, this is the properties have changed essentially. So now this is one single shape or one single curve. And this, as you can see in the surface, you just have this sewed shape, and then you also have your original projection here. Okay, so those are my first two soil strata. But let's say, for example, you have maybe more detailed more detailed data from your project site. Say, for example, in 3 dimensions, say the soil level at each of these 4 corners is different, and you would sort of want to extrapolate how that soil layer would look like in 3D. So obviously, because these are symmetric going down this plane, using the method I just showed you wouldn't work for something more complex. So in order to create a more complex surface that takes into account variations of depth in more than one plane, what you'd have to do is you'd have to go to Surface, and then you have to select one of these grid options. So for now, I'll just show you how to create your grid face because this is the most sort of straightforward way to do it. Okay, so first, when you select grid face, this option will come up. It'll ask you for the number of grid lines in each direction. So what we'll do for this one, let's make it 2. And then it'll ask you for the origin. So the origin will be 0, 0, which is this point here. So that's sort of your point of reference. And then it'll ask you for your length in the X and the Y direction. So that's essentially the area of your rectangle. So this is a 60 by 60, with the origin over here is at 0. So what we'll do is we'll type in 60 and 60, and then just try to imagine 4 lines. One's going perpendicular to the x-axis in this direction, and another one is perpendicular to the x-axis as well in this direction, and then there's another grid line, 2 other grid lines perpendicular over here crossing. So you'll get a total of 4 nodes, and that'll come up in the elevation point here. So you have 4 different nodes that you want to sort of tell the program where the depth is. So each of these nodes, so 1, 1, that represents a coordinate, and these numbers here represent the depth of your soil or your surface in the Z direction. So the best rule of thumb is always just to have some kind of spreadsheet available. Even though this is a 2x2 spreadsheet, I still have my elevation coordinates ready for me. So what I'll do is I'll copy them, and I'll paste them, Control V, and I'll select OK. So now let's take a preview of what our surface will look like. Okay, so let's take a look here. So this is the surface I've created, and actually let me turn off the solid to get you guys a better view of it. Okay, so as you can see, each of the coordinates, or each of the points in each of the four corners has a different elevation, or actually these two are both at 10. So let me bring up the elevation table here. So this point over here would be 1, 1, and this is negative 10. Then this point over here is 1, 2, and it's negative 10. And then if I go around over here, I believe this point is, or actually this point over here, sorry, let me zoom in. This point over here is point 1, 2, or actually, excuse me, it's 2, 1, and it's negative 3. And this point is 2, 2, and it's at negative 5. So using this option, you can create surfaces that are far more detailed and that are far more sort of intricate than your simple sort of straightforward flat layers. And let's say, for example, just before I move on, I want to show you guys something else. Say, for example, you had something more detailed, and say you had wanted to create a 3x3 grid. Okay, so instead of just just 2 lines along the edges, you'd have 2 lines along the edges plus another line going through the center. So imagine, if you can, just sort of a 4x4 grid, and now you'll have 9 nodes instead of 4. So let's turn on the elevation. It'll ask for 9 nodes. Let's say, for example, I have these coordinates ready. I select this box, Control V. Okay. Now let's take a look at what our surface will look like. So as you can see, it's much more sort of complex. So as you can see, because of our different elevations, the program was able to sort of extrapolate how the soil layers or the soil contours would change in 3D. And then just using this type of application, I could create something sort of more detailed or more contoured. So this option becomes increasingly more useful for larger scale projects where you have very sort of varied contour diagrams that maybe you'd want to import. So it's really important that if you have a type of project like that, just to understand how this grid range works. And then also, because I know there are certain programs out there like contour modeling, etc., that'll take all of your contours and input them in spreadsheets. So using this option, you can just copy and paste those coordinates directly into your elevation data, and it'll be created in your program. But once again, this is sort of a simpler, smaller scale project. So let's keep it simple for now. Let's put in just our original coordinates. Okay, so that's what we'll use. Okay, so now I have my my different layers created. But as you can see, the program still just recognizes just one sort of large block of soil. So what I want to do is I want to divide my layer, or divide my solid, by these various layers. So in order to do that, just go to your solid option and select this icon here, divide by surfaces. Excuse me, not trim solid. Divide solid by surface. So first select the solid that you want to divide. So it'll be this large sort of block here. So we'll select it. And now it'll ask you for your tool surfaces. So first let's divide using this bottom surface here. So what we'll do is we'll select the face. So just go along the edge here and you'll be able to select it. Okay, so make sure to check on delete original shape and delete tool shape. If you check on delete tool shape, that surface will be deleted after this is done. And since we don't need that surface after the cut, we can check that on. And select this. As you can see, it's sort of in darker green here. That's just telling you where the cut will take place. So click Apply. And as you can see, now I can select this bottom layer here. So now this larger layer has been cut by that surface. So now I have 2 sections instead of the original one. And I need to follow that same process with these other 2 surfaces. So first, let's select this top surface, or this top solid. We'll be dividing that. Now we can select the tool surface. So another very important thing to note is because this has two planes. Technically it's sort of a 3D element. It's not not necessarily a surface, not a 2D surface or a planar surface. So what we need to do is we need to change our selection option from shape. From shape, from face to shell. Then we need to select this. Okay, so that's very important. If you don't change your selection option from from face to shell, you won't be able to do the cut correctly. Okay, and then we'll leave these two options on. Delete original shape, delete tool shape. We'll preview it real quick. So as you can see, the surface will be deleted. That's why it's showing up sort of transparent. And then this dark green line just represents where that cut will take place. So we can click apply. Now we have 1, 2, 3 sections from which to choose. So now we just need to cut using this final layer here. So what we'll do is we'll just select that top solid. We'll select the tool surface over here. Okay, and then we'll also check on this option, divide touching faces of neighbors. So as I'm sure you've all noticed already, this particular cut touches the excavation sequence area. So whenever you're cutting a solid and it's touching a neighboring solid, you want to have this option checked on. So that way in the future, you'll be able to have nodal connectivity. So in other words, when we do our meshing, all of the nodes will line up. So make sure to keep that in mind. Whenever you're dividing a solid and there's a neighbor sort of element involved in the cut, to check this on. Otherwise, if you don't check it on, you'll have some errors in your analysis. Okay, so what we'll do is we'll preview it. That's what it looks like. Okay, so click apply. And now we have those 4 layers. So what we'll do, just to make things simple for us, as you can see, all of our names don't really match up here. They just have the sort of the names that come with it, in which it's not really easy to tell. So what we'll do is we'll just change the names real quick. So we'll change this to bottom layer. Enter. And in order to change your names, just select your element or your solid and press F2. And then you can change the name accordingly. Name this third layer. Okay. This one, we'll name it second layer. And then for this top portion here, we'll just name it top layer. Okay. So now all of my my names are more easy to recognize, and this is particularly important because this is a construction stage analysis, and I'll need to have everything labeled correctly in order to sort out my construction stages. So something I want to do is I want to make this more transparent so that I can see into the excavation sequence. So what I'll do is I'll press Control A, so I'll have everything selected, right-click, and then select Transparency, and let's set it up to 8 or 7. And as you can see, now I can see into my excavation sequence. And also, what I want to do is I want to make sure all of these faces here are duplicated. So this bottom face, this top face, and then all the faces along the sides of the excavation to ensure nodal connectivity. So what I'll do, just go over here, go to Surface, and then check this option here, check surfaces or check duplicates. Then click Apply. Then as you can see, all of our duplicated surfaces show up in yellow. So why is this important? This is important because later on when we do our meshing, we want these faces to be shared. If the program doesn't recognize that these faces are shared, the analysis won't run properly. So when we do our meshing, when we create our nodes, nodal connectivity will be established between each of these layers just automatically by the program. Now say for example, like these layers were hollow and say this top part in yellow didn't show up. Later on when we do our meshing, our nodes won't line up because the program won't recognize these faces as shared, and then the analysis won't run. So the reason I'm sort of stressing upon this point is because something I've realized with the training sessions with other engineers or with just doing technical support is this is a very sort of key step that a lot of engineers miss when they first start doing 3D modeling. So it's always a good rule of thumb before you go on to your meshing to check your surfaces to make sure, one, that your soil strata faces are shared. In other words, that when you have a strata, that this part here is in yellow, and then also that your excavation sequences or your excavation layers are shared as well. So as you can see, each of these each side of this box here is yellow, which means that all of this is shared. So then the analysis will run properly because nodal connectivity will be established. Okay, so that's just one thing I wanted to bring up. And I'm sure maybe some of you who maybe aren't familiar with 3D analysis still have some questions for me, but just wait till the end, and then we'll address those later on. Okay, so now that I have my layers created, or my essentially the foundation of my 3D geometry created, my next step would be to create my meshing. So first, let's switch to the top view here. So one thing that I want to do before I go on with my meshing is I want to establish the sides of my seating, or the size of my meshing along these certain areas here. So go to Mesh, then go to Size Control, and then select Along Edge. So there are different ways that you can specify your meshing seeds, but let's choose Along Edge for this one because it's the most straightforward. And then now we need to select the edges that we want to sort of control. So later on when we do our meshing, the program will recognize, okay, I've selected certain edges and I want the seating to be this coarse or this fine along the edge. So select edge and then check on polygonal. That way you can select your edges a lot more easily. Once again, it's this icon here. And then change to number of divisions. And let's change this to 10. So there'll be 10 divisions or 10 spaces for each of the edges that I specify. So what I want to do is I want to specify these edges here. Let's just hold on a second. There we go. So make sure you click on this, otherwise you won't be able to select your edges. There we go. So just these edges here, I want to specify 10 divisions. As you can see, this part was missed, so let's check that. Select that. Okay, so now these edges, I want to specify 10 divisions. Let's take a preview. So later on, when I do my meshing, these are like how many nodes will be along each of these edges. Okay, perfect. So click Apply. Okay, and now also I want to specify a certain type of meshing just along the corners here. So what I'll do is I'll select these corners, for example. Okay, and let's say I want to specify maybe 5 divisions for these. Okay, so maybe some of you are wondering how I decided upon 5 or 3. It's really just sort of dependent on your aspect ratios. So you want your aspect ratios to be 1-to-1 for your meshing, and once the meshing is done, I'll give you a better idea of what I mean by that. But just essentially, if you want the area sort of further away from the excavation, you want to have a larger meshing, and this is just sort of a good way to ensure that. So actually, I missed these sections here. So let's choose those. Okay. Let's take a look. Okay, that looks good. And as you can see, these smaller edges here, I'm going to give them a smaller division size because since they're smaller, they don't need as many sort of divisions. So I'll click Apply for those. And then lastly, I'll select these. Sort of edges here. And since they're much smaller, I'll just make them 2 instead of 5. Okay. And then click Apply. So in doing this, I'm just able to ensure that I have a more efficient sort of meshing. I mean, you could go on and do the meshing without specifying your seating size, but your analysis could take longer. I mean, if the program just does it automatically, it'll maybe create a finer mesh where it doesn't need to be created. So in specifying your mesh size or your seating spacing before you do your meshing, you're just able to ensure that you can have something more efficient. So now that I have my seating created or my seating specified, the next thing I need to do is just create my meshing. But before I do that, let's define some attributes here. So another great benefit of SoilWorks is that you're actually able to import material properties and structural properties directly from previous files. So let's say, for example, I have a project that is very similar to this, and I have very similar material properties that I want to just import into the program instead of having to define them all over again. So all I have to do is go to Model, go to Property, and then select Attribute. So you can see I don't have any material or structural properties defined yet. So let's go to Import, and then you can just select any one of your previous GTS files and just choose what material properties you want imported. So I have a completed version of this program or this project. So I'll just double-click there. And as you can see, I have all of these attributes that I already defined. So what I'll do is I'll just import all of them. Click OK. And now I have all of my material and structural properties ready for me. And then, once I create my meshing, I'll assign, these various material properties to them. So that's something that can save you just a lot of time in the long run, especially, if you're a longer time GTS user and you have all your material properties sort of defined in previous files. Instead of having to redefine them, you can just import them, and that'll save you, a couple of minutes. Okay, so now my material properties are defined. I can create my meshing. So first, let's change it to the top view. And let's mesh this top, let's mesh the excavation portion first. So let's turn off everything except for the excavation portion. So we'll turn off the second layer, the top layer, and then the third layer. Where's that bottom layer? There it is. Okay, so now I just have the excavation portion showing. Oh, and actually, since I created my surfaces already, I can just delete these curves. So I'll select all of them here, and then just press delete, and you can get rid of them. There we go. Okay. So in order to create your mesh, just go to Auto Matte Mesh, and then select this icon here. So here you can mesh 1D elements, planar elements, 2D elements, or solids. So let's select the solid option, and then select this top layer here. Okay. Division, just go to 1. It'll just go to the sort of the conditions that you specified earlier. And then select your material attribute, so we'll select topsoil. And then this is also very important as well. Under mesh set name, make sure to name it something that you'll be able to recognize easily later on when you're defining your construction stages. So let's name this EXC1, same as the solid name. And then preview here. And as you can see, the seeds are what I specified earlier. And then click Apply. So that's my first layer. Okay. And now I need to do the same thing for my remaining layers here. So let's select the second layer, leave the seeding at 1, or the divisions at 1, excuse me, and then select midsoil instead of topsoil. And let's name this excavation 2. Get the preview. Okay, looks good. Click Apply. Okay, perfect. Now we want to select the raft, so we'll select this solid, division 1, and let's leave it at midsoil for now. And then to change the name to raft, preview it, okay, apply, and then same for this embedded layer here. So this is the embedded limit. Okay, and we'll preview it. Okay, looks good. Okay, so this, for this, what I might want to do later on, say for example, I have maybe a more refined analysis, I might want to go back and add an extra sort of seed here, because the aspect ratio, like in general, you want to avoid sort of longer elements. So this is about, I'd say maybe like a 1:5 ratio, which is passable, but ideally you'd want something closer to this, a 1:1 ratio. But once again, this is just a demo, and I want to sort of get you guys to the results faster. So we'll leave this here for now, but just keep that in mind that you'd want sort of a shorter aspect ratio. So once again, I might want to go back and change the seeding or specify the seeding for this layer here. But that's passable, that's doable for now. But for more refined analyses, for final submissions, you'd definitely want to change your aspect ratios just to be safe. Okay. So those are my that's my excavation layers. And then now what I want to do is I want to create my my mesh set for my retaining wall. So first, in order to do that, we have to turn off this mesh set. So if you go to the work menu here to the left and open up the mesh option and open up mesh set, see all of my mesh sets are available, and I named them all accordingly, so it's very easy to recognize which corresponds to which. So let's turn all of these off, and then let's turn on the solids again. So just go along here, okay, and then put on the top view and go to geometry, and then go to extract, or excuse me, let me double check here. Go to the face here. Okay, yeah, you'd go to, excuse me, you didn't go to geometry, you'd go to model, and then you would go to element, and then you go to extract element. Okay, so sorry about that, I got a little mixed up. All right, so now you'd select your faces. So obviously we want the 4 faces of the excavation. So we just box it in like this, or we'd window it. And as you can see, it's highlighted in pink. So that's those are the faces that I'll want to create the meshing for. As you can see, the attribute's already listed. So when I created my attribute for the wall, I already specified it as a 2D sort of planar area. So select it to wall. It's my only option because it's my only 2D sort of attribute that I've created. And then just let's preview it. Oh, that's not preview. That actually erased it. Sorry about that. All right, so let's select the faces again. Okay, and then let's name this wall. And then let's click apply. Okay, so that's the meshing for our wall. Oh, and I missed a portion here. So that's actually, let's select those. So yeah, it's always good just to check in 3D just to make sure you selected everything. So actually, let's just let's go here since I want this all to be one mesh set. So let's delete this mesh set, and let's try this again. So go to model, element, and then go to extract element over here. Okay, so the reason I'm doing this again is, if I created a second mesh set, I would have had, 2 different mesh sets for the retaining wall, whereas I only want one. So it's really a good rule of thumb to just have everything selected beforehand. And then let's name this wall. And then click apply. Okay, so there we go. So now I have my full mesh set for all portions of my wall. Okay, so now I just need to create my mesh sets for my various sort of soil layers. So let's just turn all of these on, and let's turn on the soil layers as well. So if you want to just turn everything on, just uncheck this and then check it on again, and everything comes up. Okay, so let's start with the top layer. So you just go to Auto Mesh, and then go to Create or Auto Mesh Solid. Select your top layer here, Division 1. And then let's assign the topsoil to it. And then always, make sure to name your mesh set. So this will be top layer. Then we'll take a look at it. Okay, looks good. Apply. Okay, so one thing before I continue, as you can see, it's very important that whenever you have like a large opening or an excavation point, that the mesh becomes finer around it. So as you can see, as it gets closer to the excavation, the mesh becomes more coarse and more fine. The reason we want the mesh to become more fine at these areas is to get a more detailed sort of analysis later on. So as you can imagine, it's really the area right around the excavation point that'll be of most interest to you. You want to check the stresses and the deformations there. So in order to get more detailed results, you just want a finer sort of mesh set or elements here. And that was the whole purpose behind doing the mesh seeds, so that the program would recognize, I set this to 10 and, this equally to 10. So the program would recognize that as I get closer to this point, the mesh would become finer. So that was sort of the whole purpose behind doing the mesh seeding at the beginning. Okay, so now let's just finish up the rest of these mesh sets here. So let's do the second one, Division 1. Now let's change this to mid-soil now. Let's name the second layer. Take a look. Okay, and it's always just a good rule of thumb to make sure that all of your nodes are where you want them to be. So that looks good, so I can apply it. And then same with the third layer. So we'll select that, and we'll keep this to mid-soil for now. This will be third layer. Check the nodes. Okay, and then we'll select the bottom layer. So we'll put this to bottom soil and bottom layer. Apply. Okay, so there we go. So now that we've done our meshing, we've done all of our 3D and our 2D meshing, but as you all remember, we do have those pile elements, and because later on we do want to analyze the effects of the excavation or the the moments and the shear stresses on those piles, so we'll need to mesh the piles as well. So in order to do that, let's get a better view of them. Let's turn all the meshing off, and whoops. Okay. Let me move this over here. Sorry, let me just move this around here. There we go, back to normal. Okay, so let's actually turn off the excavation layers as well. So now all we see really are the piles in the original frame. Okay, so in order to create 1D meshing, what you'd have to do is you'd go to Auto Mesh, but instead of going to create 3D solids or 3D elements, you go to Auto Mesh Edge. So you'd select certain planar elements, or not planar elements, 1D elements or lines that you want meshed. So let's go over here. And then we just need to select our edges. So we just select the piles themselves. Number of divisions, we can just do 1. And then attributes already been selected for a pile. So as you can see, in the beginning, I already defined the attributes to have 1D, 2D, or 3D properties. So the program just filters them, automatically for you. And let's name the mesh set pile. And we'll get the preview. So there's only one node at each end. That's fine. And then click apply. So now the piles have been meshed as well. So now the program recognizes that these are not only lines, but these lines represent piles with certain structural attributes. So that would be how you'd assign those properties to them. Okay. And now also I need to create certain interfaces. So let me just double check to see how I make those. Okay, interface elements. Let me just double check here. Okay, so you'd go to model, and then you go to the element, excuse me, and then you would go to create pile. So, as you can see, the program has a specific command for creating piles. So that way, it sort of expedites, any of the other processes that come with creating those pile elements. So as you can see, it's a very simple command. It's just a matter of finding it. So create pile element in 3D. Okay. Select the elements. So we'll select the piles. Obviously, missed one. There we go. And then select pile to soil interface. So this will tell the program to specifically calculate the interface between the pile and the soil. So for soil structure interaction type projects, you'd have this option available to you, and this is specifically important, for example, for seismic analysis. So yeah, that's how you would account for soil structure interaction. And then friction interface element, that's fine, and then just click apply. Okay, so not only do we have the soil elements created, so that now they have the material attributes assigned to them, but we also have pile to soil interface specified for these piles here. Okay, and another thing that we want to do is, as you can see, I have pile to soil interface, but I also have pile to raft interface. So I want to examine the interface, or the sort of the relationship between the piles that are embedded into the raft and the raft itself. So in order to do that, I need to turn on the raft. So let's turn that on. Okay, and let's get a side view here. And what I need to do is I need to go to, well, first off, later on when I do my construction stage analysis, the material attribute of this layer needs to change. In other words, I'll be excavating the soil from here, and then later on I'll be replacing it with a pile, or not a pile, excuse me, with a raft. So first and foremost, let's go, we need to select this raft here, and we need to specify a change in parameter. So go to Model, go to Element, and then go to Change Parameter. Okay, so select change the attribute, excuse me, from 1D or from 2D to 1D, And then now we just need to select the parts of the pile that are embedded inside the raft. So just change this from mesh to 1D. Select those edges here. So all of those points here, the program will recognize that we want a pile to raft interface study. So just click apply, and that's specified. Okay. And then actually changing the sort of material parameters is a step later on, but before I do that, I just wanted to define the boundary conditions. So let's do that. Let's turn on all the solids. Actually, let's turn off all the solids and turn on all the meshing. And then in order to define your supports, you would go to Model, then you go to Boundary, and then Ground Supports. So as you can see, the program just can automatically recognize once you have your meshing created and you have all of those parameters specified. It's just a matter of telling the program that you want the ground supports defined. So let's name this just ground support. Consider all mesh sets, so all these mesh sets are being considered for the supports, and then click apply. So as you can see, all of your pins have been imported there, or have been included into the model now. And so now that I see them, I want to hide them for now because they're sort of in the way. Go from model to analysis in the work window, turn on boundary, and then check off the ground supports. So now they're still there, but you just can't see them. Okay, and now we'll also need to create boundary conditions for the piles themselves. So go to Model and just turn off all the meshing, and then turn on your pile meshing. Actually, turn on the curves as well. Actually, let's double check here. Let's get a better view. Okay, and then go to Model, Boundary, and then Supports, and we'll name this set Piles. So I have the the pile selected, along with all their nodes. And the direction of freedom, let's restrict it in the z direction. So just refer to this axis here. This is your global coordinate system. So even though my work plane has changed, the program is referring to the local coordinate system, not the global coordinate system. So once again, it'll be rotation in the z direction. So just refer to that. And then let's take a preview. Okay. And then just click apply. So now I have my boundary conditions for my piles as well. So now I need to define the loads. So go to what we want a pressure load on the raft. Let's turn on the raft. Oh, I'm getting some feedback here. I think maybe someone's unmuted. Let me double check. Okay, that's better. Okay, so as I said, I want to put a distributed load on the raft. So first, let's turn on the raft mesh set. There we go. And let's turn off the boundary conditions for the load, or the piles, so you can get a better view. And let's get a side view of the raft itself. So once again, these options are very useful whenever you're defining your material properties, etc. So just keep these sort of options in mind when you're sort of shifting from view to view. So now let's go to, actually while we're at it, let's create our self-weight as well. So this is very simple. So just go to Model, go to Load, and then self-weight. So it'll be according to the sort of local axis. So it'll be in the negative z direction. Let's name this self-weight and put -1 in the z direction, and then just click OK. So now in my load section, I have the self-weight defined. Okay, so yeah, as I was saying, in order to create the pressure load on the pile raft, just go to Model, and then go to Load, and then go to Pressure Load. Here it is. And before I continue, as you can see, the program or GTS has all these different sort of load sets that you can create. So for higher end projects or projects that are very specific with their loading, you should be able to select from these loads, these load options listed here. So for example, temperature load, temperature gradients, etc. If you want to account for expansion due to increases or decreases in temperature, you'd be able to do that just using these loads. But once again, for this project, all we need really is just a pressure load, so we'll select that option. And then let's name this load set raft load. It'll be a face pressure. And then we want to select the element face, so go here. And then we just want to select this top face here. There you go. And then directions in the normal direction, and then we want to be, I believe, 200 kilonewtons. So let's, another good thing that I sort of missed was that if you want to change, excuse me, your units in the middle of your modeling, just go to the bottom right here and just click on this drop-down menu. And as you can see, the program just automatically changes them. So for example, if I were to put 200 kilonewtons, but I wanted to change it to tons for whatever reason, I could just go here, and the program just converts it automatically. So that's just a useful option in there for GTS. Okay, and then let's preview it. And this is what the distributed load will look like. So I just want to make sure that I didn't accidentally select one of these faces. Otherwise, I might have a load going in the lateral direction. But so far, it looks like the selection went well. Okay, so just click Apply or OK. Either one's fine. And now you have your pressure load on the raft. And let's turn that off for now, just so we can see a thing better. Okay. And now the next thing we need to do is we need to change the element attribute. So as I alluded to earlier, at one point during our construction stage analysis, we want the program to recognize that this particular mesh set is no longer has the soil attributes, but we want it to recognize that it has raft attributes. So in order to do that, go to Model, Boundary, and then go to Change Element, or Change Element Attribute for construction stage. So the difference between these two is, say for example, you accidentally meshed this, but you gave it the wrong attribute, and you realize later on, like, whoops, this has another attribute that I need. You'd go to this option, and this would just change it just in general. But for example, for a construction stage analysis where you have a layer that changes attributes from one construction stage to another, you would use this option instead. So select the mesh set, select that, and then instead of topsoil, we want this to change from topsoil to raft. Okay, and then just click Apply. Okay, so what all these sort of dots represent, it's just letting you know that all of these sort of finite elements, they have a certain boundary assigned to them where you can change the attribute later on further down your construction stage. So if I go to Analysis and if I go to Boundary, as you can see, it corresponds to a boundary. And later on when I'm defining my construction stages, I'll show you how to sort of specify this change in material attributes. Okay, so now let's turn on all of our meshing, and let's go back. So as you can see now we have, all our geometries created, our meshing is done, our attributes have been defined, our loading, our boundary conditions, etc. So now it's just a matter of defining the construction stages and running the analysis. So in order to define your construction stages, go to Model, go to Construction Stage, and then go to Define Construction Stage. So for those of you who are curious, Stage Definition Wizard, let's just open this real quick. This is for sort of larger scale construction stage analysis processes. For example, if you were to be working on a very high-end project, for example, maybe a high-rise building foundation, you would have, maybe a couple of dozen construction stages, So you would use this option to create your construction stages very quickly. So as you can see, it just goes on and on. So these are for more complex and more detailed construction stages. For example, if many of you have maybe a higher end project that you're working on where you'd need this sort of interface, we'll talk. We can set up a sort of a private or a customized session. But since this is a very sort of specific and sort of a higher end option, what we'll do is we'll just use a simpler construction stage analysis tool for now, just the define construction stage, which is for smaller scale type projects such as this and much more commonly used. So what you need to do is just go to Define Construction Stage and then select New. Okay, now all of this is available to you. So what you have here to your left is all of your set data. So this corresponds to the work tree. So everything I created, or everything, all the attributes that I defined are here and available to me. That's why it's so important to label all of your mesh sets and your boundaries and your loads clearly. Otherwise, it's very difficult to sort of see what corresponds with what. So as you can see, everything's been defined clearly, so now I should be able to do my construction stages. So for the first construction stage, it'll just be initial site conditions, before what the project site looked like before you came in and did the excavation. So this will just be initialization. And another great feature here, let me see if I can move this over. There we go. Okay. If you type in show elements activated, you can actually see what sort of mesh sets you're including. And let's put clear displacement here. All right, so you can actually see what mesh sets you're including. So for example, when I drag and drop bottom layer into activated data, it shows up here to the right. So this is just a good way to sort of visualize what your construction stage looks like. So third layer, second layer, then I also have my top layer. So as you can see, I still have that this hollowed out portion, which represents my excavation. So I want to pretty much bring everything over. So for example, excavation, actually it's, let's do it in a way where you can see it fill up here. So the embedded limit, the raft, excavation 2, and excavation 1. So here you just have essentially just your soil. So as far as the raft, the wall, and the piles, those won't be included yet. So initialization, good. Or the name is initialization, good. And then once you're done creating your construction stage, just click Save. So now the program will have that, just saved in the database. So now I want to move on to my next construction stage. So click New. And now you have an option to create a second or the subsequent construction stage. So let's name this one Excavation 1 or EXC1. And the only thing that really changes here, oh, and it's actually, sorry, I forgot something in initialization. Let's click yes. So as you can see, I need to put my boundaries. That's very important. So go to, go to ground support and put in your boundary conditions and then self-weight. So that's a very sort of common error. Once again, if you don't put your ground supports, your analysis won't run, and the program will tell you to check your ground supports. So yeah, just make sure to include that in. All right, and then click Save, and now go to your second construction stage. Okay. So as you can see in this second stage, everything is still activated. So in other words, sort of a common error that a lot of engineers who are new to the program make is they think that they have to, specify what's activated for each and every construction stage. But what happens here is, since this is construction stage 2, the program recognizes what's already been activated. So you don't have to, reactivate the second layer, the third layer, etc. As you can see, just in your work window here, everything is already sort of present. But what I want to do in the second construction stage is I want to deactivate the top layer here of this excavation. So just go to your set data and find excavation 1 and drag and drop it into deactivated. So as you can see, that it's starting to hollow out now. It's starting to show that, okay, this portion has been excavated. And also I want to create my retaining walls here in this section. So go to Wall and activate that. So it's sort of hard to see, so let me do it again. Just keep an eye on the edges here. And as you can see, the shading changed very slightly. So the program recognizes that at this point you've installed your retaining wall. Okay, so once you're sure that everything is what you desire, just click Save, and then click New. So now you can go to your third construction stage. We'll name this one just Excavation 2, EXC2. And then we'll drag and drop Excavation Sequence 2. As you can see, it's getting deeper now. And that's all that's really changes for this construction stage. So we'll click Save, click New. So now we're up to stage 4. So this will be just Excavation 3. And then we want to, we want to deactivate the third the third section here, which I just named a raft. So in hindsight, what I really should have named this was excavation 3 and raft, just to make it more recognizable. But so just deactivate it. So as you can see, that part's been dug out now. Click Save, and then New. Okay, so now for the fifth construction stage. So here in this stage, we're installing the piles. So we'll name this Install Piles. And we'll just drag and drop, first and foremost, the pile elements, and then the friction interface for the tips, the parts that are in the raft, or that will be in the raft, excuse me, as well as the interfaces for the parts of the piles that will be in contact with the soil. And then also we need the boundaries for the piles. So that's very important as well. Make sure to include all of your corresponding boundary sets. Okay, so that's my pile section. So save. And then my last construction stage, click New. We'll just name raft and load, because I'll be inputting my raft, or I'll be changing the attribute for my for that section, and I'll be inputting my load as well. So excavation 3. So once again, here what you want activated is the raft, but now you want to specify that this raft has been given raft conditions. So just input that boundary here, and then the program will recognize that instead of mid-soil attributes, it'll have a raft attribute. And then last, I have my raft load. Okay, so just click Save. And now I have all 6 construction stages. And it's always, a good rule of thumb just to go through and just to check to make sure everything's, imported correctly and that you have everything, activated at some point. And as you can see, it's, very straightforward as far as the excavation. Okay, but, for larger scale projects, construction stage analysis or setting up your construction stages would take a little longer, but if you can sort of get the sort of basics from this tutorial, you'll sort of be set for larger scale projects as well as projects that are similar to this. Excuse me. Okay, so now I have my construction stages created. I need to create my my analysis case. So go to Analysis, go to Analysis Case, and then go to Add. And then change the analysis type from nonlinear static to construction stage. So as you can see, all of this grays out. So let me sort of explain why that happens. So you say, for example, you're creating a linear static case. You would have to go through pretty much the same sort of follow-through that you did previously with setting up your construction stages. You'd have to drag and drop, etc. And then later on, if you had maybe a corresponding or a stage after that, you'd do deactivated segments as well. What construction stage analysis does for you is it takes 6 sort of different cases that are part of this sort of timeline, and it puts them all into a single case to make it sort of faster. So for smaller scale analyses, or analyses that would only require linear static analysis, this would be sort of more ideal. But for longer sequences that require construction stage analysis, you can just define everything using the construction stage modeler, select construction stage, and you don't have to worry about these steps anymore because you took care of them essentially in the previous step. Okay, so then go to Analysis Control, and then Initial Stage for Stress Analysis. Let's do that. And let's turn on K-not conditions. And then I'm sure some of you are wondering what nonlinear and seepage mean. These are just certain criteria that you can specify for nonlinear analysis, for stiffness methods, etc., as well as seepage analysis. So if you're doing a seepage analysis, you might want to specify the number of iterations, just depending on your project scope. But we don't really need to worry about these options for this project, so we can sort of leave them alone. So we'll just take initial stage for stress analysis for initialization. So in other words, you're telling the program that the first stage that you want to start with is initialization, if you specified. And then we want to take K-not conditions into account as well. So click OK, and then just name the stage. So we'll name this excavation analysis. Okay. Okay, close. So at this point, your last step would just be to run the analysis itself. So you'd go to Analysis, and then you'd click on Solve. And then depending on the size of your project, it could take anywhere from a couple of minutes to maybe a little longer than that. For this project, it should only take about a minute or two. But just in the interest of time, I do have a completed one. And keep in mind this is the same project. That way we can get to the results a little faster. Okay. So once again, this is the same project except the analysis has been run. And as you can see in post-processing, if you go to the left here, your this corresponds to your analysis and your model, but post-processing, it just gives you drop-down menus for all of your different stages, or all of your different stages and all of your different results. So if you go to the left here, as you can see, I have initialization, my 3 excavations, installing the piles, and then my raft. So let's open up initialization here, and let's take a look at let's element strains. So nothing's really happening, as you can tell, just because it's the initial stage. So let's close that actually, and then, or actually, let's go from that. Let's go to 3D element stresses. That might be a little more interesting. There we go. So these are the initial element stresses, and then say, for example, I want to see how they change over the course of the construction stages. I can go to this bar here, and then just using the scroll option on my mouse, I can see how it changes with each construction stage. So it's going from each construction stage, one construction stage to the next, and as you can see, the piles are being installed in that stage. And then, excuse me, get you a better view here. And then the raft is being installed at that stage. And you can see just how your element stresses or your soil stresses change with each stage. And then let's see what else I can show you. Okay, so I won't go into too much detail about all the different results that are available to you. I'll focus more on how to sort of extrude or to find the results that are of interest to you. So for example, let's go to the last stage here, and let's go to displacement. Okay, so let's go with, for example, this one here. Or actually, let me find one of, there we go, that might be a little better to use. Okay, so let's go to your displacement in the XY plane, or maybe in 3 dimensions. Let's stick here. Okay, so say you have this particular contour model is of interest to you for whatever reason, but you want to find out maybe the minimum or the maximum values. So what you would do is you'd go to Results, and then you'd select Probe Result, this icon here. And what you can do, just using your cursor, is you can double-click on certain portions that are available to you. Let's say, for example, you zoom in, and maybe this yellow area is of interest to you. You want to see the displacement over here because it looks like it's, that's where you get sort of the maximum or your maximum range of displacement. So double-click, and you can tag, just going along here, your different displacements. And then just using this legend here, you can see your exact numerical values, what your units are, etc. And then also, everything's sort of saved into the spreadsheet. So for example, with other programs that are out there, you might not have a contour graph like this. Say, for example, you're using a spreadsheet. What you'd have to do is you'd have to go through that spreadsheet and you'd have to find your results that are looking for you. That could take a while. That can be very cumbersome, especially for large-scale projects. Now, say, for example, with Midas GTS, it's much more simple. You can see certain ranges or value ranges at a glance, and then you can just extract directly, extract these results directly by clicking on these ranges. So it's much more convenient for 3D analysis, especially for creating these spreadsheets. And now, say for example, you want your maximum and your minimum values. That gets tagged, so it's right around there. And then your minimum value obviously would be 0 over at the edges where the blue is. So that's just a way that you can sort of speed up your result extraction. Okay, so that's now say for example, you have all of your 3D results, you have all of your element strains, but maybe you're wondering about your retaining walls. You want to see your 2D strains and stresses. So in order to do that, go to 2D element strains. Actually, you could go to 2D element forces. That might be a simpler one for you guys. There you go. So as you can see, I can't really see anything. The reason this is happening is because all of the sort of solids are in the way. I want to sort of specify, because my only 2D areas of option, or excuse me, areas of interest would be the retaining wall itself, right? So go to Model, and then open up your mesh sets, and then just turn everything off. And let me make a quick change here. Okay, so for example, say you want to see your 1D results for your piles. So I'll go to the 2D strains later. So just turn everything off except for your piles, and then go back here, and let's take a look at the side view. And then go back to your analysis cases, or excuse me, your post cases. Go to 1D element forces. And as you can see, because these parts are embedded into the raft, there's sort of more forces acting in these areas here. But it shows you just along the lengths of each pile what your forces are. You can get the forces in the Z direction. You can get your moment diagrams. This looks like there's no moment. There you go. Moment in the Y direction. Moment with respect to the Z direction, etc. So that would be how you to get your sort of 1D elements. Now, for example, say I want to check my retaining wall. So go back to your model. Turn off your piles, but turn on the wall itself, okay? And then go to analysis, or excuse me, not analysis, go to post. Let's close these. And then, as you can see, now you can check your various results for plates, etc., your strains. And then if you go down to 2D element strains, you can see those as well. So as you can see, you have a whole sort of wealth of data that's available to you. But just using Midas GTS, everything is organized for you. And just using various result extraction options, you can find what you need very quickly. So what else did I want to show you here? Okay, another thing. Let me just turn on the all the mesh sets now. Back to post. And then let's go back to some 3D options here. Okay, let's check the displacement actually in the X, Y, and Z. And let's say I want to see deformation. Believe, go here, no. Okay, so let's see if I can show you the deformed shape. There we go. Okay, so just using this icon here. Sorry, I kind of get these mixed up sometimes. So if you want to see sort of an exaggerated view of your deformed shape, just click on this option. This isn't, actually what it would look like, but this is just, exaggerated to sort of show you areas that may be of interest to you. So the program is telling you that these sort of areas here, these two walls, will experience the most deformation, and these, might be something that you want to check for your project. So just keep in mind that this is, very exaggerated. In order to turn the exaggeration off, just check this off. So that's how you would check your deformations. And since this is something that a lot of engineers sort of look to, our developers have made it sort of put this icon very conveniently right next to right under your post data options. Okay. So another thing that I want to show you that's very useful is the clipping plane option. So in order to do, for example, say for example I want to take maybe a cross-section view of this soil block. Say I want to see what all the values are if I cut this soil down the middle. So in order to do that, go to Result, and then go to where is it? See if I can find the clipping plane option for you. It's under here. Okay, sorry about that. So go to a post command, and really the best way to sort of find these commands is just to click on this tab, and all the icons are here for you. And then visualization. So you have different ways that you can view it. So go down to a clipping plane. And as you can see, the program just automatically sort of cuts it in half for you. But say, for example, you want it exactly down the middle. Let me see if I can move this for you. Okay, Okay, so that's, sort of what it is, down the middle here. Sorry, the view's not too great, but now say, for example, I want to shift the clipping plane in the positive Y direction. So what I would do is I just go to Define. And as you can see, let's reverse that. What I can do is if I just click on this ball here, excuse me, not the ball, if I just click on the plane itself, I can move the clipping plane. Let me zoom out to get a better view. And then also what I can do, say for example, for whatever reason I want to tilt this plane, just click on the tip of the arrow, And now you can get your clipping plane at an angle. And say, for example, I don't want it in the Y direction, I want it in the Z or the X direction. Or actually, I'm in the X direction right now. Let's say I want it in the Y direction. Click that, and let me change the view here. And I can move it around, and in the Z direction as well. So this is just an option that's particularly useful for 3D geometry. So instead of having to sort of make these individual slices, you can just very conveniently move the clipping plane along your desired level. So that's just another way that you can sort of extract your values. And I know I did it a little quick, so once again, just go to Post Command, and then just go to Clipping Plane, which is this option here. And say, for example, you're done with the clipping plane, you want to go back to the original view. Just click on Original, and you'll get back to your the view that you started with. Okay, so that about does it for this training session. Thank you again for your attendance. And what I'll do is I've noted, I've noted everyone who's attended so far. And what I'll do is I'll send out a copy of, I've recorded this entire session, so I'll post a recording on YouTube, and I'll send the links out to you guys so that everybody can access it. And I'll also send you guys a copy of the tutorial that I used. If you have any questions at all, feel free to contact me directly. I'll send out my email address to you along in the emails. But I see that we have a lot of sort of attendees here. I guess before I sort of sign off, I'm sorry, I see a question here. Is it possible to import drill holes with lithology data or to import grid surfaces from other modeling software into GTS? Okay, so thanks for the question, Jeff. So it really depends on the modeling program and the sort of format that you use. Really the best way to import any type of geometry is just through an Excel spreadsheet. And I know other programs that are out there, they have sort of that same or sort of Excel format. So for example, if I wanted to import geometry into the program, let me go back to the So as I said, just go to geometry, and if you want to import any type of datum, just go to so datum from WCS. So that's another option that's available to you. I know that with Revit, I'm not sure. I have to double check with my supervisor about Revit, but I know for MIDAS you can import Revit files. But if I wanted to import any type of, for example, points or curves, I do have for points. I have the tabular input option, but going back to your question, as long as it's in an Excel sort of format, you should be able to import the geometry directly from that program. And I know AutoCAD, you should definitely be able to import any type of geometry. So for example, go to File, go to Import. As you can see, these are all the different sort of programs that Midas GTS is compatible with. So for example, if you had a DXF drawing in 2D or 3D, you could import it. If you had an AutoCAD drawing, a DWG sort of format or FPN format, you could import those as well. So just using this import option, you'd be able to import, various geometry. And as far as the contours, once again, go to the surface again. If I want to import an elevation sort of surface, so for example, an 11 by 11, this is, I think, yeah. So if I had maybe like a terrain geometry modeler or a contour modeler, I could just import the spreadsheet directly and import it here, and you should be able to have all the exact coordinates. It's just a matter of specifying your coordinates correctly at that point. Okay, and then I see another surface. Can surfaces and solids created in GTS be exported for use in other 3D modeling packages? Okay, excellent question. So as regards to that, I'm not really too sure. I know with, for example, I'm not sure if they can be imported directly. I'm not really too sure with the compatibility with other programs, to be honest with you. I know with AutoCAD, and as I said, those programs that I mentioned, just basic modeling programs, you'll be able to import geometry into GTS. But as far as, importing entire models, for example, say you had like this model and you wanted to import it into Plaxis, I'm not really sure how much you could import. I mean, it really depends on Plaxis's import capabilities as well. So I'll double check with my supervisors for that question, and I'll get back to you with a clearer answer. But my answer for now is I'm not really too sure. One, it depends on the program, and two, it depends on what type of attributes and data that you want to transfer one program to the other. So yeah, thanks for that question, and I'll get back to you as soon as I get a clearer answer. Okay, so thanks, Jeff, for the question. Before I sort of wrap up here, does anybody else have any questions for me about this project or about what we discussed? Okay, so I don't see any questions coming yet. So for everyone who attended, as I said, I'll send up a follow-up email with just the with a copy of the tutorial that I used for this project, a copy of the completed model as well, so you can take a look at it yourselves. For those of you that are looking into GTS, I believe either Beta or Arwen will follow up with you just to see how GTS can further meet your needs. And for all of you sort of long-time users, I'll be in touch with you as well. I know I'm working with some of you on some of the projects that you're working on right now. So, we'll be in touch. But yeah, thanks again for your attendance. I really appreciate you guys attending and for the questions as well. And I look forward to helping you guys in the future with GTS. And if you guys have any questions in the future, don't hesitate to contact me. All right, thank you again for your time, and I hope you all have a good day and enjoy the Labor Day weekend.